Hello, Mr. Sutton here, bringing you the Algebra 2 Honors 10-8 Part 1 homework solutions on using angle, sum, and difference identities. This one will be focusing on evaluating and simplifying expressions with these identities. For this problem, we're trying to find the exact value of sine of 75. Now, 75 is not one of our special angles. It's not a 30, a 45, or a 60, and it's not one of the quadrantals. But we can split this up into the sum or difference of two special angles. I think the easiest way to split this up would be to think of 75 as 30 plus 45. I prefer quadrant 1 angles if I can, so I don't have to mess with reference angles. So the angle sum formula for sine, that's going to be sine of A times cosine of B plus sine of B times cosine of A. So plugging all that in, we've got sine of 45 times cosine of 30 plus sine of 30 times cosine of 45. And now just evaluating each of these individually, sine of 45, these are all special angles now. This is going to be root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 30 is 1/2. And cosine of 45 is root 2 over 2. Simplifying each of these products, we're going to have radical 6 over 4 plus radical 2 over 4. And then we can combine this into one fraction to be radical 6 plus radical 2 all over 4. To find the exact value of this expression, a good first move would be to turn this into degrees. So 180 divided by 12, that's going to be 15. And then 11 times 15, I believe, is 165. We got 10 times 15 plus another 15. So that's 165 degrees. Now that's not a special angle, and the reference angle for this thing is also not a special angle. Reference angle on this thing would be 15. So we're instead going to break this up into a sum or a difference of special angles and then use one of our sum or difference identities. So we have a lot of options always with these. I'm just going to use 120 plus 45, but there's certainly other ways you could have gone on this one. But that seems the easiest for my brain to deal with, so you do you, but this is how I'm doing it. So I'm going to use the cosine of a sum formula. That's cosine of A cosine of B minus sine of A sine of B. And let's see here. Just plugging everything in, that means I've got cosine of 120 times cosine of 45 minus sine of 120 sine of 45. So I can do the cosine and the sine of 45 pretty quickly. Those are already special values in my table. But cosine and sine of 120, I'm going to have to convert those to reference angles to really deal with those. So let's look at cosine of 120 first. So that is in quadrant 2, where the x values are negative. So this is actually a negative. And 180 minus 120 gives me a reference angle of 60. So I can think of this as the negative cosine of 60 when I actually plug stuff in there. And then for sine of 120, that's same quadrant, same reference angle, but sine is the y values, and those are positive in quadrant 2 because that's above the x-axis. So this is just going to be positive sine of 60 when I think about this in my brain. All right, so doing all these evaluations now, cosine of 120, which is really negative cosine of 60, that's going to be negative 1/2. Cosine of 45 is root 2 over 2. Sine of 120 is sine of 60, that's root 3 over 2, and that's being subtracted right there. And then sine of 45 is root 2 over 2. Multiplying these out, we've got negative root 2 over 4 and negative radical 6 over 4. And then I can combine these into a single fraction to be negative radical 2 minus radical 6 over 4. Or if I wanted to, I could make this whole fraction negative and just call this radical 2 plus 6 over 4. That's another way of writing this one. For this problem, I'm given a cosine value for one angle that's 4/5 and a sine value for another angle that's negative 15/17. And these angles are each in their own special quadrants. Based on this, we're trying to do sine of A minus B. So basic idea, just kind of thinking ahead here. This is a sign of a difference, so I'm going to need both the sine and the cosine of a and b for the formula that we're about to use on this. So let me find each of those values. I've already got cosine of a. I need the sine of a. So let me figure out x, y, and r and where those are positive and negative based on this quadrant here. And then I can figure out with Pythagorean theorem what the sine of a is. So 0 to pi over 2, that's quadrant 1. X and y are both positive there. Cosine in general is x over r. So that means since x is positive, that means x is positive 4. And r is always positive. It's positive 5 in this case. So using my Pythagorean theorem, the y value that I need for sine is going to be the square root of r squared minus x squared. So that's square root of 5 squared minus 4 squared. And that's going to be 25 minus 16, square root of 9, which is 3. So the sine of a, which is y over r, is going to be 3 over 5. So that's one missing piece that I have now. Let's look over on this other one. This quadrant between 3 pi over 2 and 2 pi, that's quadrant 4 between 270 and 360. The x's are still positive there, but the y's are negative now. And they gave me sine of b. Again, that's going to be y over r. Since this is negative 15 over 17 and we know y is negative, that means that y must be negative 15. And r is always positive. That's going to be 17. Using my Pythagorean theorem to find x now instead of y, I'm going to have x equals the square root of r squared minus y squared. So 17 squared minus negative 15 squared. This is 289 minus 225, which is 64. The square root of 64 is 8. Cosine of b is going to be x over r, so that's going to be 8 over 17. So my formula for sine of a minus b, in general, that's going to be sine of a cosine of b minus sine of b cosine of a. Plugging in all the different pieces that we have now, sine of a is right here, it's 3/5. Cosine of b over here, we found that's 8/17. And then sine of b is up here, that's negative 15 over 17, and there's already a negative out in front, so be careful there. And then cosine of a they gave us was 4/5. Multiplying things out, we've got 24 over, this is 85, and this is going to be a positive here, positive 60 over 85, which I'm not going to reduce because I need to combine like terms. So we've got 84 over 85, and that's as good as it gets. For this problem, we've got the cosine of an angle and the sine of a different angle in some different quadrants, and we're trying to figure out the tan of a minus b. So the tan formula for a difference here is going to involve the tan of angles A and B. So we're going to need to find those individual tans so we can plug them in that formula. And to do that, we have to use the information we're already given. So in general, we've got either an x or a y and an r value for each of these different angle values they're giving us. We're going to need to use Pythagorean theorem to figure out the third missing value. So for this first one, we're in quadrant 1 between 0 and 90. That means in quadrant 1, x and y are both positive. So I've already got, from cosine, I've got x over r. So that means my x value is positive 4. My r value is 5. And for tangent, I'm going to need to figure out the y value because tan is y over x. So I can do y equals the square root of r squared minus x squared. So 15 or 5 squared minus 4 squared. That's 25 minus 16, which is 9, and the square root of 9 is 3. So tangent in general is y over x. So the tangent of a then is going to be 3 over the x value 4. So that's one missing piece. Let's get the other one. We know that in quadrant 4, which is what 3 pi over 2 to 2 pi is, that's 270 to 360, we know that x values are positive, but y's are negative there because you're below the x-axis. So we've got sine, that's y over r. Since y's are negative, that means we have a negative 15 over a positive 17. And then to get the x value, I'm going to do x equals the square root of r squared minus y squared. So 17 squared minus negative 15 squared. This is 289 minus 225. That's 64. Square root of 64 is 8. Again, tan is y over x. This time we're doing tan of b, though. So we've got a different y over a different x. So in this case, we've got negative 15 over positive 8. Now the tan of a difference formula, that's going to be tan of a minus tan of b over 1 plus tan of a times tan of b. And we've got tan of a and b. We just need to plug them in. So this is going to be 3/5 minus negative 15 over 8. So plus. And then we have 1 plus 3/5, or 3/4 rather, times, again, negative 15 over 8. And we have to simplify this. So I'm going to simplify the numerator and denominator separately, and then I'll probably have to do some multiply by the reciprocal business to get to the bottom of this. So in the numerator, we need a common denominator to add these together. So if I just multiply this first fraction by 2 over 2, I can think of this as 6 over 8. And adding that to 15 over 8 would give me 21 over 8. In the denominator, we've got 3/4 times negative 15/8. So that's going to be negative 45 over 32. And I'm going to simplify the denominator kind of in my head, and then I'll multiply by the reciprocal of whatever I get down here. So we've got, this is essentially 32 over 32 minus 45 over 32. That's going to be negative 13 over 32. The reciprocal of that is 32 over negative 13. So that's what I'm going to multiply, 32 over negative 13. Now I'm supposed to be able to do this without a calculator. So to kind of help me along, I'm going to cross cancel or reduce the 8 and the 32. That gives me a 1 down here and a 4 up here. And now I can just multiply straight across. 21 times 4 is 84 over negative 13. And that's as good as this one's going to get. For this problem, we're trying to simplify the expression cosine of x minus pi over 2. The most straightforward way to do this is to use an angle difference identity for cosine. That would be cosine of a cosine of b plus sine of a sine of b for this one. So cosine of x times cosine of pi over 2 plus sine of x sine of pi over 2. Cosine of pi over 2 we can simplify. That's the x value at 90 degrees, so that's 0. So we have cosine of x times 0. And the sine of pi over 2 is 1, so this is sine of x times 1. Well, 0 times anything is 0, so that first term goes away. 1 times anything is the anything, so that leaves us with just sine of x for this one. For this problem, we're trying to simplify tan of x plus pi. So I'm going to use my tan of a sum formula on this one. So that's tan of, in general, tan of a plus tan of b over 1 minus tan of a tan of b. So we've got tan of x plus tan of pi over 1 minus tan of x times tan of pi. The tan of pi, that is the slope at 180 degrees. Since that's a horizontal line, essentially, that's a slope of 0. So we have tan of x plus 0 over 1 minus tan of x times 0. So tan of x plus 0 is just tan of x. This term down here is just 0, so we have 1 minus 0, so just 1. Tan of x divided by 1 is just tan of x.